A magnitude 7.0 earthquake just struck near the border of Canada and Alaska, right in the heart of one of the most seismically dangerous zones on the planet. And no, this isn't just another tremor buried in the back pages. This was a major event, and it's ringing alarm bells across the entire Pacific Ring of Fire. The quake didn't just shake the ground, it cracked open a harsh reminder of what this region sits on top of. And
if you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one.
Intricate, overlapping network of fault lines and tectonic boundaries capable of producing historic levels of destruction. The Alaska Subduction Zone, the Queen Charlotte Fairweather Fault, the Cascadia Megathrust. These aren't just geological terms, they're some of the most feared fault systems in North America. And this quake hit right in their backyard. The seismic shockwaves were intense. Roads split, bridges took damage, utility poles went down. Local infrastructure across several communities was visibly impacted. In some areas, landslides complicated access. And all of this unfolded in the middle of winter, under freezing conditions that made rescue and response even more difficult. Helicopter rescues were deployed in areas cut off by road damage. Emergency crews worked under relentless weather. Community shelters had to be activated fast. And this wasn't a one-and-done event. Aftershocks came fast and furious, more than 40 of them in just 24 hours. And some of those aftershocks were strong enough to cause their own share of destruction. Seismologists are closely monitoring every inch of ground displacement, every shift in fault stress. Advanced radar imaging, GNSS ground tracking, and waveform analysis are being used to map the rupture and model what comes next. Because this isn't just about what happened. It's about what could happen now that tectonic stress has been released or transferred into neighboring fault systems. That's the real concern. This event didn't just relieve pressure. It may have moved it. And in a region with such a volatile tectonic setup, stress transfer can lead to even bigger problems, larger aftershocks, or, in a worst-case scenario, a cascade effect that wakes up one of the sleeping giants in the region. So far, the immediate tsunami threat has been ruled out, but not everywhere is off the hook. Coastal zones, especially fjords and inlets, are still at risk of localized surges. If a landslide hits the water, the amplification effect could send a destructive wave crashing into a nearby shoreline with barely any warning. And that's exactly what scientists are watching for right now. This is where hazard modeling comes into play. These aren't just theoretical warnings, this region has a track record. Scientists know that steep terrain and active faults under stress are a dangerous mix. Landslides, soil liquefaction, structural failure, these aren't fringe risks. They're front and center. In many ways, this quake serves as a litmus test for regional preparedness. Emergency response was swift, but conditions were harsh. Snow-covered roads and sub-zero temperatures made logistics incredibly difficult. Communities scrambled to restore power and assess damage while still under threat from ongoing aftershocks. And even as infrastructure assessments continue, the broader concern looms large. Is this quake an isolated release, or part of a larger sequence building beneath the surface? That's where the historical context matters. The 1964 Alaska earthquake was a 9.2, the strongest quake in North American history. It caused widespread devastation and triggered a massive tsunami. And long before that, in 1700, the Cascadia Megathrust erupted with a quake so massive it sent a tsunami all the way to Japan. These systems don't move often, but when they do, they leave scars that last centuries. That's the type of geological potential that surrounds this current event. No one's claiming a 9.0 is next. But in a tectonic environment like this, a 7.0 isn't the end of the story, it could be the beginning of one. It could mean increased stress along segments of the Queen Charlotte Fault, or further instability in the Cascadia Zone, or even triggering movement along previously locked sections of the Alaska Subduction Zone. And this is why scientists are investing heavily in continuous monitoring. The current modeling efforts are using satellite imaging and seismic data to track how much the ground moved, where the fault slipped, and how energy was redistributed. These models help predict the probability of aftershocks and assess risks for neighboring zones. It's not just about one quake, it's about how one quake can destabilize an entire tectonic region. This level of scientific effort isn't just academic. It directly informs emergency planning, infrastructure reinforcement, and public safety protocols. The quicker and more accurately the science community can interpret what's happening underground, the more effectively governments and communities can respond above it. And make no mistake, this is not a low-risk region. The Pacific Ring of Fire is a hotbed of seismic and volcanic activity, stretching across continents and touching some of the most densely populated zones on Earth. It includes subduction zones, transform faults, and strike-slip systems, each with its own unique potential for disaster. The Canada-Alaska boundary, sitting right in the thick of it, is under constant stress. This quake just reminded everyone of that. In the days and weeks ahead, scientists expect hundreds of smaller quakes to follow. Most won't be felt, but any of them could cause additional structural stress or trigger secondary hazards. That's why the region remains on high alert. Recovery and response efforts are happening in parallel with risk assessments and community readiness drills. This is where the balance between data and preparedness becomes critical. You can't stop earthquakes, but you can mitigate the impact. Early warning systems, resilient infrastructure, and public awareness all play key roles in surviving a tectonic event, not just the main shock, but the ripple effects that follow. Right now, the data is still coming in. Ground displacement is being mapped. Stress points are being analyzed. But what's already clear is that this wasn't just another tremor. It was a major tectonic event that hit a critically sensitive region at a time when the Ring of Fire is showing signs of heightened activity. Preparedness now becomes the priority, because the science is still unfolding, but the Earth has already made its move. If you're in the region or any zone along the Ring of Fire, stay alert. Stay informed. Aftershocks don't schedule appointments. Landslides don't wait for daylight. And seismic chains don't always end where they started. Drop your thoughts in the comments. Let us know how your community is holding up, what you're seeing on the ground, or how you're preparing in the days ahead. And if you want more breakdowns of events like this, real and filtered and fact-based, go ahead and like, share, and subscribe. The next quake won't warn you, but we will. This earthquake didn't just hit a remote border, it hit a geological bullseye. A location so stacked with tectonic pressure, it's like trying to play Jenga with dynamite. You've got the Alaska subduction zone, one of the most powerful seismic sources in the world, literally diving beneath the North American plate. Then there's the Queen Charlotte Fairweather Fault, a major strike-slip system just itching for motion. And lurking nearby, the Cascadia megathrust, an infamous sleeping beast that's been gathering tension since the 1700s. So when a magnitude 7.0 rocks this exact zone, scientists don't just raise eyebrows. They drop everything. Because here's what's not dramatic, it's factual. This area has everything required for a megathrust quake. It's not a matter of if. It's a matter of when. And this latest quake, it's potentially the first domino. Even without a catastrophic collapse, this 7.0 already did more than enough. Roads fractured. Bridges took structural damage. Utility poles were snapped like toothpicks. And let's not forget, this wasn't summer. The quake hit during harsh winter conditions. Rescue crews weren't just navigating broken roads, they were battling snow, freezing temperatures, and limited visibility. Helicopter rescues had to be launched just to reach isolated communities. Relief crews were flying in emergency supplies. Some towns found themselves effectively cut off, not just by geography but by geological chaos. And that chaos kept on rolling with every new aftershock. In just 24 hours, more than 40 aftershocks rattled the region. Some were strong enough to do real damage on their own. And the tremors aren't over. Experts are forecasting hundreds more in the coming days. Not because they want to scare people, but because that's what the data shows. This is a classic aftershock sequence. It's what happens when massive amounts of stress get released and redistributed. That redistribution is key. Because when one fault slips, it doesn't disappear into silence. It sends stress outward like a shockwave, pressurizing nearby faults. That's what scientists call stress transfer. And in a place like the Canada-Alaska border, it's a recipe for ongoing instability. This quake might not be the end of the story, it could be the opening chapter. That's why every inch of this event is being dissected in real time. Ground deformation is being measured with GNSS monitoring systems that detect even millimeters of movement. Satellite radar imaging is mapping the fault rupture from space. And waveform data is helping researchers model the slip dynamics, so they can understand exactly where and how the crust gave way. These tools aren't just cool tech. They're critical for forecasting what happens next. They tell us whether adjacent segments are more likely to rupture. They show if the stress has loaded into shallower areas. And they help authorities make decisions about emergency readiness and infrastructure safety. Right now, scientists aren't just watching this fault, they're watching everything nearby. Because this quake might have nudged other systems into instability, especially Cascadia. The megathrust zone just south of the impact area has been silent for over 300 years. That's longer than it should be. And many believe it's overdue for a massive rupture. It's worth repeating, the 1700 Cascadia quake was so powerful, it sent a tsunami across the Pacific Ocean and struck Japan. That's the kind of legacy these fault systems have. And when one shakes, the others don't ignore it. The other major issue here is the secondary risks. Everyone's focused on aftershocks and damage, but what often causes the most destruction after a major quake isn't shaking, it's the landslides, the road failures, and the hidden threats in places people don't expect. In this case, landslides are a very real problem. Steep terrain combined with winter freeze-thaw cycles is already unstable. Add seismic shaking, and you've got entire hillsides ready to collapse. That's how you get impassable roads, buried communities, or worse, sudden death traps with no warning. And then there's the water. The broader tsunami risk might have been ruled low, but localized threats still remain dangerously high. In fjords and narrow coastal inlets, a landslide into the water can trigger a wave that behaves nothing like a typical tsunami. It's fast, it's close range, and it can strike before an alert system has time to activate. Alaska's already seen this happen before. Scientists have long warned that glacier retreat and unstable slopes along fjords could create sudden landslide-driven tsunamis. With this quake and its aftershocks increasing slope instability, that possibility is now front and center. And this isn't a fear-based story, it's what hazard models are showing. These models, built on decades of seismic and geological data, show exactly where danger zones are, and they're lighting up. The science is loud and clear. This region remains in an active phase, and the threat is ongoing. All of this begs a bigger question. Are we seeing a new pattern emerge along the Ring of Fire? Seismic clusters aren't uncommon. And when you start seeing large quakes popping off in major fault zones, it's not just a coincidence. It's a pattern of activation, a potential shift in tectonic stress across the entire plate boundary. The Ring of Fire has a long, brutal memory. It's not one zone, it's a chain reaction waiting for the right spark. And if this quake is part of that chain, the implications stretch well beyond the Alaska-Canada border. That's why this quake matters on a global scale. It's not just a regional issue. It ties directly into how the Pacific Plate behaves. And if stress is building or shifting here, other regions from Japan to South America are watching closely. Because in the Ring of Fire, what happens in one corner often ripples into the next. So what does this mean for the people living through it right now? It means remaining on alert, watching for updates, preparing for the possibility of more tremors. It means not underestimating the secondary hazards like landslides, road collapses, or localized flooding. And above all, it means staying engaged with the science, because that's what gives us the edge. What's clear right now is this: the ground beneath the Canada-Alaska border has moved in a big way. And it's still moving. This was a 7.0 magnitude quake in one of the most tectonically dangerous intersections on Earth. And it's triggered a storm of seismic activity, scientific analysis, and emergency response efforts, all unfolding simultaneously. As researchers track each shift in the ground, as communities assess damage and navigate recovery, and as emergency teams brace for more tremors, the region finds itself in a state of tense watchfulness. The question isn't if more shaking will happen, it's when, where, and how strong. Because earthquakes don't work on schedules. They don't give warnings, but they do leave clues. And the clues this quake has left behind suggest we're in the middle of something bigger than just one jolt. This is what it looks like when Earth decides to remind us who's in charge. A 7.0 magnitude quake isn't just a number, it's a blunt force signal that the tectonic machine is awake and turning, whether we're ready or not. And when it hits a region like the Canada-Alaska border, where three of the most volatile fault systems converge, that message hits differently. Everything about this event screams, pay attention. Because while the ground may have stopped shaking for now, the consequences are still unfolding. Emergency crews are still racing to assess damage under freezing conditions. Engineers are inspecting bridges and overpasses for fractures, while power crews work to restore downed utility lines in remote, snowbound areas. And across the region, communities are dealing with the logistics of road closures, blocked access, and the very real fear that the next tremor is just a matter of time. You've got people trying to get to work, only to find the road literally cracked open. Schools trying to reopen after closures only to be interrupted again by another aftershock. Local governments coordinating emergency response plans, with one eye on the shaking ground and the other on weather reports predicting another round of storms. It's chaos, but it's controlled chaos. For now. Still, there's this underlying tension. Everyone knows that the 7.0 might not have been the worst-case scenario. In this region, it rarely is. That's why scientists are swarming the data, because what they're seeing could point to a broader tectonic escalation. Not just here, but across the Pacific Plate. Let's break that down. The Ring of Fire is not one fault. It's thousands. Subduction zones, strike-slip faults, transform boundaries, all tightly interlocked along the edges of the Pacific Ocean. And when something shifts along one of these margins, it can destabilize others. That's the domino effect. And right now, that effect might be in motion. The quake near the Canada-Alaska border struck in a zone where stress has been accumulating for years, possibly decades. And now that energy has been released but not fully, it's been redistributed. And that's where things get dangerous. Because tectonic stress isn't eliminated, it's transferred. It's passed along fault lines like a bad baton in a high-stakes relay race. And if it lands in just the wrong spot, say, a locked segment of the Queen Charlotte Fault, or a long quiet section of Cascadia, we could be looking at a chain reaction. That's not alarmism. It's basic seismology. And it's why current monitoring efforts are so intense. Ground sensors, satellite imaging, and real-time seismic networks are all being used to watch for changes no matter how small. Scientists are looking for any hint that another segment is primed to rupture. They're also analyzing surface displacement. This quake didn't just shake the ground, it moved it. In some places, land shifted laterally or vertically by several inches. That might not sound like much, but on a geological scale, that's massive. It means the plates are actively adjusting. And they're not done yet. Then there's the question of how this event affects the region's volcanic systems. The Ring of Fire isn't just about earthquakes. It's also home to over 75% of the world's active volcanoes. And while no immediate volcanic activity has been reported from this quake, geologists are keeping a close watch. Because when tectonic plates shift, magma chambers feel it. In some cases, significant seismic events have been known to trigger unrest in nearby volcanic systems. It's not automatic, but it's a known risk, and it's part of the reason why so many scientific teams are involved right now. The regional implications are serious, but so are the lessons. This quake exposed vulnerabilities in infrastructure. It reminded everyone just how quickly life can grind to a halt. And it showed that even the most remote regions can face massive, coordinated emergency response efforts when nature decides to turn up the pressure. Let us know if you've felt the aftershocks or if your area has seen infrastructure issues. Is your town still dealing with outages? Are emergency crews active in your community? We want to hear how people on the ground are dealing with it. And if you're following this story because you care about the reality behind these events, not just the headlines, but the science, the impact, and the aftermath, make sure to like, comment, and subscribe. Stay informed, stay aware, and most of all, stay ready. Because the ground might look still, but in the Ring of Fire, stillness is just the calm between chapters.